All right, what's up, guys? Okay, getting a little bit ahead. So I'm going to post this way early and I'm going to try and stay ahead so that you guys can kind of work at your own pace as much as possible and try and balance pre-calc with the rest of your other classes. I'm going to try and bring a little more energy to the video. It's a little bit hard when I'm not interacting with you guys because I'm used to interacting with you guys and cracking jokes and stuff. So let's see what we can do. Go ahead and pause me for a second and write all that stuff down. And this is the second part of 7-6. We did double angles last time. We decided all of the pre-calc teachers are in agreement that we're actually not going to test you on half angle formulas. I might give you a very small quiz on something involving the half angle formulas, but they will not be on the test next Tuesday. The 28th, I think. And I'm going to show you one of the reasons that we don't particularly, there's other ways we can do these problems. So first let's evaluate one using a half angle, and then I'll show you the alternative. Notice that these are essentially the same. So if you can remember which one is plus and which one is minus, you really only have to memorize kind of like one thing. For some reason, it just makes sense to me that the cosine formula is plus cosine. Also notice that this is just the sine over the cosine. If you don't see it, I would like you to actually work it out. Do this divided by this, and you'll see that you end up getting that. Because when we divide by a fraction, we multiply by the reciprocal, and then the 2's will end up canceling out. One will be on top and one will be on bottom. We'll talk about this when we work the problem out. Okay, so let's look at this. We have sine of 105. That's what we're looking at here. Sine of alpha over 2. That's an alpha, Greek letter. I can't remember if we've talked about, I'm pretty sure we talked about that with the sum and difference formulas. So I want to figure out 105 is equal to what over 2, right? Because I'm saying these two things are equivalent. So that means that alpha must be 210. Multiply both sides of this equation by 2. Multiply both sides of this equation by 2, and you get alpha equals 210. So we're going to say that sine of 105 is the same as sine of 210 over 2. I think everybody can agree with that, right? And then we're just going to apply the formula. So our alpha is 210, so I'm just going to plug in big square root 1 minus cosine of alpha. Now, we can't do 105 in the unit circle. Let's look at this. Let's back up a second. If I had 105 in the unit circle, that would be barely past 90, right? It's how much, what would be the reference angle there? So I would need another 75 to get me to 180, right? And we don't have a special right triangle which has a 75-degree angle. So we cannot evaluate sine of 105 without a calculator. We would have to use a calculator and then round the decimal, so we couldn't get an exact value. This formula allows us to use cosine of 210 instead. That I can evaluate. So cosine of 210, I want you to draw a triangle. Figure out what quadrant it's in and find the reference angle. Pause me. Okay, so 210, hopefully you have in the third quadrant. It's 30 degrees past 180, right? And we can label all the sides just because I feel like we probably need some practice. The unit circle, right? So the radius or the hypotenuse of the triangle is 1. Across from 30 is 1/2, and since it's going down, it's negative. And then if that's 30, then this is 60. Across from 60 is rad 3 over 2, and it's negative because it's going left. So remember that the cosine is the x over r. So cosine of 210 is negative rad 3 over 2. I have 1 minus in front of that, divided by 2. We'll talk about the plus or minus at the end. We could talk about it at the beginning, but I just prefer to talk about it at the end. So I'm going to give these a common denominator. No, I'm not. That's not how I do these problems. I tell you guys to do these by multiplying to get rid of the fraction, don't I? When we have fractions within fractions, we want to multiply by the LCD. So this has a denominator of 1, this has a denominator of 1, and this has a denominator of 2. So the LCD is 2. So I'm going to multiply by 2 over 2. I'm going to distribute on top. So that 2 times 1 minus 2 times, plus, right? Minus negative. 2 times that fraction, the 2's are going to cancel out, over 4. And then you might remember a rule from Algebra 1 that tells us if we have a big fraction under a radical, we can take the radical of each thing separately. We can take the square root of each thing separately. So I'm going to take the square root of the top. I'll show this step, even though it feels tedious. I'll show that step. Square root of the top divided by square root of the bottom. Oop, I almost just made my radical way too big. And then the square root of 4 is just equal to 2. The square root of 4 is equal to 2. Now let's evaluate whether we should do the plus or the minus. The thing that people make mistakes on is they're thinking of the 210. Don't think of the 210, okay? Think of this. It's as simple as this. This question is asking me to find sine of 105. I drew a picture for 105 right here. Is sine in the second quadrant, sine in quadrant 2, right? Is it positive or negative? Should this answer be positive or negative? 105 is in this quadrant, right? And sine goes up, so it's positive. That's all I need to do. Just think about, should that answer be positive or negative? Okay? So if sine was down below, I would choose the negative. When sine is up above, I choose the positive. When cosine is along the positive x-axis, I choose the positive. When cosine is along the negative x-axis, I choose the negative. Okay? So my answer to this question is positive 2 plus rad 3 all under a radical over 2. Okay? Now, I promised an alternate method. I'm going to do it here. I want to save some paper, so I hope this doesn't mess with anybody. So I'm going to do a different method to show you why we have decided in this crazy world we're living in right now that we're not going to emphasize half-angle formulas too much. So let's go back. Sine of 105. I bet you've already done that on your homework before. It's been a few days, but I bet you've already done that. We learned sum and difference formulas. We can break this up into two angle values that we know how to evaluate. 105 is equal to 45 plus 60. This is exactly the same as this. And then we can apply the song, sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? Hopefully you've practiced that enough. Sine, cosine, cosine, sine. I don't clap for the first part of the song, so the sine, S-I-G-N, the positive matches the positive. Sine, cosine, cosine, sine, right? And then I go 45, 60, 45, 60. And then I want you to pause me and evaluate that. So hopefully you got sine of 45 is rad 2 over 2. Cosine of 60 is 1/2. If you need to draw a picture, draw yourself a picture. Hopefully you don't need a picture for the 45s. Ideally you don't need a picture for this, but it's okay if you do. Cosine of 45 and sine, sine of 60, the y value. So we end up with what? Root 2 over 4 plus root 6 over 4. And those have a common denominator, so I can smush them together. And I have my answer. Why doesn't that match? You're like, shoot, we got it wrong. Which one did we mess up on? We didn't get it wrong. They're just different fractions for the same decimal. So I'm going to show you square root of 2 plus square root of 6. Oops. Oh, okay. I'm just going to start over. square root of 2 plus square root of 6. Third time's a charm. Swear to God. Okay, square root of 2 plus square root of 6 in parentheses, because that's on the top, over 4. Gives me that decimal. I'm going to get this one on the first try, guys, I swear. Square root of 2 plus square root of 3, okay, divided by 2. I'm going to put parentheses, even though I don't think we need them. I'm pretty sure we don't, but I'm still going to do it. Okay, so square root of 2 plus square root of 3 underneath still, right? That's still under the radical, divided by 2, gives me the same decimal. Okay, so that's the same, it is the same answer. It's just a different fraction. Okay, so that's it for this section. I'm only giving you, I think it's 5 problems. So practice that. And remember, I will give you a small quiz on this, but it is not going to be on the test. I hope you guys are doing well. I miss being in class with you guys. I miss seeing your faces and laughing and being silly and joking. But I hope you guys are doing well.